So for this slide, you're going to be grouping these statements together with the ones that go together. And how do you know they go together? Basically, they mean the same thing. Or maybe you could think of it as one is used as a justification for the other, depending on the situation. So I'm going to start with f of x is increasing. So my original function is increasing. That means the original function's slope is positive. So that should match with a first derivative that is positive, if I can actually find one in here. There it is. F prime of x is positive. All right, so let's see what else we have here. F of x has a point of inflection that has nothing to do with that. So I'm going to put it down here and see if something else goes on there. And there are a couple, but here we go. F of x is decreasing. So for that one, it should be f prime of x is negative. The slope is negative. And here it is up here. All right. Concave down, that looks separate. F of x changes concavity. That's a point of inflection. So I'll group that one down there. F prime of x changes from decreasing to increasing. That is actually also a point of inflection. So we'll go here. F prime of x changes from increasing to decreasing. Point of inflection. Let's see what else. F double prime of x changes signs. Remember that the second derivative goes with concavity. So if we change concavity on the original, then the second derivative is going to change from positive to negative or negative to positive, which is why these two go with it as well. If f prime changes from decreasing to increasing, that means its slope is changing from negative to positive, which means its slope, the slope, is changing signs. So these are all having something to do with points of inflection. All right, let's see what else we have here. We have f of x is concave down, and I see an f of x is concave up. That's separate. So I'll put that away from that one and see if there's anything else about concavity. And there is. It's what we have down here. F prime of x is decreasing. That, a decreasing first derivative, goes with a concave down original function and a negative second derivative. Those three go together. They are all the same thing. So if f of x is concave up, that's going to go with the second derivative being positive and f prime increasing. So I'm running out of things to do here. All right. So if f of x has a relative max, we put that here, scoot this one down. If f has a relative max, then I know the graph went up before the max and went down after it changes from going up to going down. So that means the slope f prime changes from positive to negative, and we have f prime changing from negative to positive, so a graph going down then up would create a relative min, and those are grouped according to which ones are the same.